Wonderful. We are thrilled that you could join us on this Friday afternoon for New Technologies, New Dilemmas. My name is Carmel Shachar. I'm Executive Director of the Petrie-Flom Center for Health Law Policy, Biotechnology, and Bioethics at Harvard Law School. We have organized this event. Before we start, I just want to say if this is something that gets you excited, something that you want to spend Friday afternoon, then we also have a host of other events throughout the year that are open to the public that we would love to see all of you guys at, if you're local or if you want to choose to travel. Our events this year range from a panel on drug pricing to discussing preparing vaccines in the face of public health epidemics like Ebola and Zika, to a look at the framing of disability and how it affects our medical and legal systems. So great things. If you are interested, if you have questions about our center or about our events, please come talk to me afterwards. We also have some folders, or find us online where you can sign up for our newsletter. Now, when I introduce panels, I try to keep things relatively short in the introduction so we can get to the part that we care about, the meat of the discussion, but we have such a distinguished panel that even their short bios are quite impressive and long. So please bear with me as I introduce our distinguished panelists. The first panelist we have is Glenn Cohen, who is actually one of the very first Petrie-Flom academic fellows. He is currently a professor of law at Harvard Law School, as well as our faculty director. He is one of the world's leading experts on the intersection of bioethics and the law. His current projects relate to big data.
Stop. Go on to someone else.
No, I want to take the chance to embarrass you thoroughly. But they relate to a variety of really important health law topics: big data, mobile health, reproductive technologies, research ethics, organ transplantation, medical tourism. It really runs the gamut. He's the author of over 95 articles and chapters, as well as a lot of work in less scholarly venues, such as op-eds in the New York Times and the Washington Post. He's the author, editor, or co-editor of 9 books, including some with our center, such as Big Data, Health Law and Bioethics, as well as the Oxford Handbook of U.S. Healthcare Law. He's a fantastic teacher. He was awarded the HLS Student Government Teaching and Advising Award in 2017. He's also created for the public a free online Harvard X class, Bioethics, the Law, Medicine, and Ethics of Reproductive Technology and Genetics. He was selected as a Radcliffe Institute Fellow and by the Greenwald Foundation to receive a Faculty Scholar Award in Bioethics. Before he became a professor, he served as a law clerk to Judge Michael Boudin of the U.S. Court of Appeals for the First Circuit and as a lawyer for the U.S. Department of Justice. So now that I've embarrassed Glenn, let's move on to Judy. So Judy Edersheim is co-founder and co-director of the Center for Law, Brain, and Behavior. She's also an assistant clinical professor of psychiatry at Harvard Medical School and an attending psychiatrist in the Department of Psychiatry at Massachusetts General Hospital. Her research interest is in the translation of psychiatric and neurologic behavior into legal settings. She's published articles in a wide variety of settings, including medical journals, such as the Journal of the American Academy of Law and Psychiatry, as well as legal journals, such as the Massachusetts Family Law Journal. She has performed a wide variety of forensic evaluations in both civil and criminal settings, including evaluation of competencies to stand trial, testamentary capacity, and the capacity to make medical decisions. She is a principal lecturer in the Forensic Psychiatry Fellowship at MGH and teaches forensic psychiatry to adult psychiatry residents at both MGH and McLean Hospital. She graduated from Brown University and Harvard Law School. She then clerked for the Honorable Robert W. Sweet, United States District Judge for the Southern District of New York. She then went back to school, went to Harvard Medical School, and afterwards completed a fellowship in the Law and Psychiatry Service at Massachusetts General Hospital. Moving on to Atul Gawande. He is the executive director of Ariadne Labs. He is also a surgeon, professor, writer, and public health researcher. Dr. Atul Gawande practices general and endocrine surgery at the Brigham and Women's Hospital and is professor in the Department of Health Policy and Management at the Harvard T. Shands School of Public Health, as well as a professor of surgery at Harvard Medical School. He's also chairman of LifeBox, a nonprofit reducing surgical deaths globally. He has focused his research on problems at the intersection of surgery and public health. Much of his work looks at errors in surgery, such as establishing its frequency and seriousness and revealing underlying mechanisms. He is an influential writer, as I'm sure many of you know. He writes the Notes of a Surgeon column for the New England Journal of Medicine and has been a staff writer for the New Yorker magazine since 1988 and has written 4 New York Times bestseller books. He has received numerous awards, including 2 National Magazine Awards, Academy Health's Impact Award for the highest research impact on healthcare, the MacArthur Genius Award, and the Lewis Thompson Award for Writing and Science. Last, but certainly not least, we have Eric Lander. He is president and founding director of the Broad Institute of MIT and Harvard. Professor Lander is a professor of biology at MIT and professor of systems biology at Harvard Medical School. He has also served as the co-chair of the President's Council of Advisors on Science and Technology for President Barack Obama. He is a geneticist, a molecular biologist, and a mathematician, and he has played a pioneering role in the reading, understanding, and biomedical application of the human genome. He was one of the principal leaders of the Human Genome Project. His honors and awards include the MacArthur Fellowship, a Breakthrough Prize in Life Sciences, the Albany Prize in Medicine and Biological Research, the Dan David Prize of Israel, the Mendel Medal of the Genetic Society in the UK, the Award for Public Understanding in Science and Technology from the AAAS, and the James R. Killian Jr. Faculty Achievement Award from MIT. We are truly lucky to have such a panel together to discuss these really important issues of how new technologies challenge our understandings in both the legal and ethical frameworks of what it means to be human beings, good citizens. The rules of the game for the next hour and a half is that our presenters are each going to present a little bit of their research, of their work, what interests them about this topic. We're then going to have a short moderated discussion between them. But don't worry, because after that moderated discussion, you all will get a chance to ask questions. And with that, I turn it over to our first speaker. Judy will have to walk across everyone to reach the podium.
Thank you so much, Carmel, Glenn. It's a tremendous honor to be on this panel, and I'm really very happy to be here today. I'm going to speed talk, and I'm going to oversimplify, and I'll get to the caveats when we get to our discussions. So we have a wonderful ongoing collaboration with the Petrie-Flom Center. I'll talk a little bit about that later. And I'm very excited to see a lot of my friends from the class of 1985 in this room. That said, as a law student, I spent much more time with someone else. I met him in torts class, and he followed me for all 3 years at Harvard Law School. He was, of course, everywhere, and he was the reasonable man. It should be in a different view here. There we go. So what was the reasonable man like? You all know him if you're ever law students. Well, he was older than 13. Let's call it the bar mitzvah rule. And he lived forever. His faculties never dimmed. His individual experiences and memories had no effect whatsoever on his thoughts and behavior. His values were universal, independent of culture or country, and he was a pinnacle of virtue, courteous, gentle, careful, very perceptive. Why hang out with him? Well, because the reasonable person, then the reasonable man, set all the standards. The law is about mental states, and it was his mental state that mattered. Here are just a few examples. Negligence is the failure to do what the reasonable man would do. Defamation is something that would make the reasonable man think less of you. Foreseeability is how far into the future the reasonable person can see. And the excuse of provocation is available to you only if the reasonable man would have been provoked under the same circumstances. As the great jurisprudence professor John Gardner said, the reasonable person is someone who's justified whenever justification is called for. And most important for today's discussion, the reasonable person had a reasonable brain, with an impeccable set of ancestors, as you can see. From Aristotle, he inherited his memory. His memory is laid down perfectly on a blank slate, and he always remembers everything perfectly, especially when he's in court. From Kant, he inherited his autonomy, his independence. He always knows and advocates for his own interests, without social pressures or any undue influence. From Descartes, he inherited perfect reason, free from all emotion, and because his reason is unencumbered, he foresees the consequences of all his actions, and he accurately weighs the risks and benefits of everything. And finally, from Mendel, please try not to faint, Professor Linder,
Okay.
he inherited a brain fixed from birth with a static genetic code. So here's the dilemma.
We'll talk.
So here's the dilemma. Over the last 50 years, neuroscientists have developed the ability to see both static brain structures and dynamic brain function. These tools that you've all heard of, CT, MRI, fMRI, PET, SPECT, and the discoveries they enabled show that the reasonable brain is largely a myth. Brains, and the people who house them, aren't always average. They don't operate independent of age, circumstance, emotion, and experience. To pretend otherwise in legal doctrines causes fundamental injustice, particularly at the beginning and the ends of the life cycle. And I'm going to talk about both of those, adolescence and old age. I'm going to talk quickly. So let's talk about the teenage brain. It turns out that the bar mitzvah rule is incorrect. Teen brains are significantly different from adult brains, and from an adult perspective, there's nothing reasonable about them. Why? Because adolescent brains are not fully developed. There are two important systems that are developing at different rates. An adolescent neuroscientist would talk about the dual systems model. Certain structures that play an important role in processing social and emotional regulation, in the valuation and the prediction of reward and punishment, those develop very early in adolescence, and these structures show early high activity. The upshot is a hypersensitivity to rewarding stimuli. So think food, sex, money, Brits. That's what teenagers are about. So other structures, cortical structures, which subserve regulation, self-regulation, self-control, those develop later. And the disjunction between those developing systems explains a lot about how adolescents behave. The sensation-seeking, the risk-taking, the volatility, the impulsivity. This imbalance declines somewhere, and there's a big debate, maybe 22, maybe 25, maybe 26. And neuroscientists who study adolescent brains talk about three things in particular. These are gross oversimplifications, but they're very useful simplifications. So what do they talk about? They talk about gray matter, they talk about white matter, and they talk about dopaminergic systems. So I'm going to go very quickly. You can ask me later, but I've gotten 5 minutes. Gray matter is the thing you know the name of. Gray matter are the structures that contain the computational bodies, the neuron bodies that actually do computational work. And gray matter shrinks during adolescence. And you say, why is less more with gray matter? Shouldn't we want more of that good stuff? And the answer is no. This pruning that happens to gray matter in adolescence is actually critical for cortical maturation. And it's an enormous amount of pruning given the number of years, on the order of maybe 17%. While gray matter is shrinking, white matter is expanding. You can think of those as the processing superhighways of the brain. And the increase in the volume and connectivity of those pathways actually makes for metabolic efficiency and communication efficiency, and all of that comes together really at late adolescence. And finally, signaling. One reason why adolescent brains are not mini adult brains is that they have high levels of a neurotransmitter called dopamine, and circulating dopamine, the highest concentration of it in a lifetime, and the highest number of receptors for that lock and key kind of brain transmission. Well, dopamine is important for the reinforcement and motivation to action. Dopamine motivates teenagers to seek rewards, and it stamps in memories that are of motivational importance. So the high activity of this system explains why adolescents pursue rewards in the environment in a very exaggerated way. Think money, think arousal, think thrills, in an exaggerated way like this. Idaho teen lights driver's armpit hair on fire, causing crash.
Seemed like a good idea.
Right? And guess their ages, 15 to 18. Now I show you this, no one was seriously hurt, but really? Really? That's a good idea? Okay, so what does this mean? It means they're risk takers. They're impulsive, they're irresponsible. And the bigger question is, what are we going to do about this knowledge in the legal system? Should we raise the age? Should we shrink juvenile sentences? Should we change conditions of confinement to ensure healthy neurodevelopment? Should we rethink criminal law doctrines that rely on a mens rea that simply doesn't exist if you're 12 or 13 or 14 or 15? These are very important questions. We'll get to the caveats later because I have a whole end of the life spectrum to cover. All right, so that's the teenage brain in all of its glory. What about the aging brain? Let's go back to the reasonable person. The law enshrines a concept of the brain which, for the most part, is ageless. Probate law, contract law, consent law presumes almost complete autonomy until death. Well, the fictional man might retain his faculties forever, but real people don't. 50% of Americans in their 80s suffer from significant cognitive decline. 2 million new cases of dementia are diagnosed every year in the US. By 2050, estimates are about 19 million Americans will have Alzheimer's disease. And that doesn't count all the other types of dementia. How do we know? We know from bioimaging, we know from CSF assays, we know from scans, we know from the clinic, we know from clinical investigation. So we don't have time to discuss neuroimaging in any detail, but in general, we have remarkable tools for scanning the human brain. We can look at brain tissue, like with that MRI. We can look at metabolic activity. We can look at blood flow. And when we look at this brain tissue, we can even use special scans that visualize neurotransmitter systems or look at amyloid plaques. You would frankly be amazed. And what it shows, here I'm showing a slide that shows that we can actually see markers of neural degeneration before the presentation of clinical disease. Subtle abnormalities might be detectable in asymptomatic, no symptoms, asymptomatic individuals nearly a decade before Alzheimer's disease is diagnosed. And these markers are becoming very common. Why does this matter? Why it matters is that if the law keeps insisting on an ageless brain, despite the increasing prevalence and morbidity because of these neurodegenerative disorders, people are going to be sick, and they're going to be neglected, and they're going to be poor. The annual cost associated with dementia care are about $259 billion this year. In addition to personal care is a big problem that many of you will be dealing with in your practices, which is financial problems. Over the next 55 years, $60 trillion are going to be passed down from the estates of the elderly. Who's paying attention to this combination of money and cognitive decline? Fraudsters. So internet scammers, undue influencers. So experts are calling elder financial exploitation the crime of the 21st century. And I can go into the billions if you want to know. The repairman scam, the lottery scam, the grandparent scam. Many of you have actually experienced or know people who have experienced these scams. The jury pool scam. So the next area where neuroscience is going to have a great impact on the law is going to be in the field of elder law. We can use our biomarkers, neuroimaging techniques, neuropsychiatric batteries to debunk the myth of the ageless brain and start to revise these really crusty doctrines of consent and undue influence and testamentary capacity. We have an ongoing project at the Center for Law, Brain, and Behavior on dementia and the law, and our fearless leader, Professor Shan, is sitting right here. I'm glad to see him. So we have him available for the Q&A if I'm promised. So this is a very interesting aside, and I'm going to end here. If you happen to be on campus 2 weeks from now or want to come back, please join the Petrie Flom Center and the Center for Law, Brain, and Behavior. We're going to speak to this very issue regarding aging politicians and judges. Very timely indeed this week when the DC local pharmacist on Capitol Hill says he regularly delivers Alzheimer's medications to Capitol Hill. Thank you very much.
I'm going to sit here if that's all right with you, and follow on that because it nicely paints the description of from childhood all the way through to the end of life. And what I like thinking about is the effect of our medical technologies at that macro level as well. In the spring, with two economists, Kate Baker, who had been in the Bush administration, and Ben Summers, who's a liberal physician economist, we got together to study the last 10 years of data around what is the connection between our policies in health, and specifically our policies on coverage and our health. And it's relevant because it tells us some information about how we think about the lifespan and how that influences a variety of different areas. When we studied that data, we were looking at Medicaid expansions over the last 10 years and then the last 5 years of the effects of the ACA. And what we found was that as you increase people's access to coverage, they get more access to treatments, they get more access to specialists, they get more access to emergency rooms. They are better off financially when they get that care. They're less likely to be bankrupted, their medical debt goes down. And after 1 to 2 years, there is no mortality change. So then the puzzle has been, what is going on? Why, if we've increased people's access to care for all of that care along the lifespan, does it matter? Does the coverage that we've been battling over for the last year matter at all? And what we found is you need to look longer. The value of getting care is more incremental. And so what you see is after about 5 years, there are substantial reductions in death. There are substantial improvements in health. And what you slowly learn is that the course of connecting our medical technologies and our health interventions to how you actually do takes a long time because the key channel is having a regular source of care and being able to afford your needed medications. When you have a regular source of care and can afford your needed medications, after 1 to 2 years, people report they feel better. About a 25% increase in the likelihood that you find you are in good to excellent health. 25% increase. Mental health has significant improvements with a 1/3 reduction in depression by about 1 to 2 years out. And then by 5 years out, you have substantial reductions in death. In the largest studies comparing states that expanded Medicaid versus those that didn't, you had a 6% reduction in mortality and an ongoing increase in reduction in mortality of 1% a year going on after that. And the biggest reductions in mortality were occurring in people, and this starts to make sense now, who have chronic illness. People with cardiac disease, people with HIV, people with cancer. And I think that data tells us something that's really important to understand. We have two images of life. One is the dominant image that governs our national debates and in many ways the ways that we play out our policies. And that's that life is a period of more or less steady health with intermittent crises. And you want to have access to the rescue care for those crises like a house that's on fire, you want the fire department. And then you come in and you put out the fire, the disease is stamped out, and then patched up and put back to your former state of health. And then you go on until the next crisis, and then have that patched up, addressed, the fire put out, and move on. And that, of course, is wrong, but that's the way we built our health system, is in a concept of thinking of these as being insurable critical moments. And instead, what life looks like is, following on Judy's description, it is the accumulation of chronic issues, first the development of your faculties, and then the accumulation of chronic issues. And part of the story of the technological growth of medical care is that we're able to stave off some of those chronic issues, but most of the pattern is that we're better and better at managing your life with those chronic issues. 1/3 of the adult population has hypertension, and controlling that, which is the biggest killer in the country, is one of the most critical things that you have access to along the way. Those are the interventions, those step-by-step incremental steps that manage over time that are, besides public health interventions, have been crucial in taking us from a place where in 1900, the average person only lived into your 40s. That was the typical life expectancy. And in one century, we have made it so the typical person who has a regular source of care lives into your 80s. In the space of that time that short, we've extended life, less than 100 years, extended life by more than 40 years. And when you understand that that is what, it's not just the individual technologies of what they do, and it's the collective effect of our capabilities that becomes really interesting. The future of medicine is increasingly personalized. And what that means is that we have more and more capacity to understand data about you before disease happens. Our discoveries in the 1950s were we could give you penicillin once the pneumonia came. We could intervene with a cardiac operation once the disease hit. We could do the first kidney transplant after you developed the kidney failure. But our knowledge now is about what's ahead of you. It started with the simplicity of being able to understand how high blood pressure or smoking might affect you, but now it's your genetic code, and now it's your zip code, which is just as important as your genetic code in predicting what might be ahead for you, and then many, many other pieces of data. Your shopping history is an important guide to what you're likely to do. The information on your phone tells us about what your sleep habits are, your cognitive interconnection, your social network, and all of those pieces of information tell us a lot and more about what's ahead for you. And the integration of that data about what is ahead by a clinician and a patient in a relationship around deploying technologies to serve your goals in life, that is what creates those 80-plus years in good health and with well-being. There are major implications. We'll talk about some, but I'm going to name 3. One is in the realm of pre-existing conditions. 27% of people, 27% of adults, 27% of you, have a pre-existing condition that would have made you uninsurable if you went out to buy health insurance before the Affordable Care Act. Now, the significance is not just that you have 27%, but in the time since the Affordable Care Act, the data we have been able to create make it so all of you are pre-existing conditions waiting to happen. The fact that we can use your genetic code, your zip code, your buying history, and so on to tell us about what's ahead makes it so we can segment people and everybody has a pre-existing condition waiting to happen. Next issue is that catastrophic coverage as a model is a kind of disaster. The problem with the reason our healthcare debate seems so stymied is that it's not just about whether the proposals to make a cheaper version of the ACA or to reduce the dependence on government rolls, it's not just that they result in 15 to 32 million uninsured. It's the vision of plans that produce a $5,000 deductible without any primary or chronic care coverage. that are that coverage for that HIV, for the cancer care, for the hypertension, for other things that are crucial to how long you live. The third implication is that we are living longer lives with accumulating disease, and therefore have, at present, on average, about 8 years of significant disability in which you will need the assistance of others during your life. And then the question becomes, we're still in that model of treating every health condition as if it is a house fire that we're trying to rescue, instead of understanding it as the accumulation of disease. And so our goal remains in our financing system and the care we provide, and in the law, the idea that our goal is the continual fixing of parts. And the problem is that as frailty sets in, the continual fixing of parts, the narrow focus on disease, results in increased costs, a lack of reserves in the rest of your body to compensate for that effort to fix the parts, and so increased suffering, and reduced survival. So very few benefits from the spending of 25% of our Medicare dollars in the last year of life. Our goal is neither survival at all costs, nor a good death, but as good a life as possible all the way to the very end. And I'll finish by saying that the key lesson out of this last point about thinking of the arc of life is that as we navigate that arc, people have priorities in their lives besides just survival. Those priorities and goals for their life and for their care change over time and are different from person to person. The key, therefore, is to ask people what their priorities are, and we don't ask. We ask in healthcare or in other circles less than a quarter of the time. We simply assume your goal is safety and survival at all costs until you tell us otherwise. The result is suffering, because our care is typically out of alignment with your goals and priorities when we have not asked. And I'll finish with a story. As part of my last book, Be Immortal, I did more than 200 interviews with people who had terminal illness or advanced disease. And among them was an 85-year-old woman who had advanced Alzheimer's disease. She'd reached a fairly advanced stage, so she was ordered to have a medically ordered pureed-only diet because of the concern that she could choke. And then she would be caught in her nursing home stealing cookies from her neighbors. And they would confiscate her cookies. And they would write her up and call the kids. We'll have to kick her out if she doesn't obey the rules. And the rules are, it's not safe to eat those cookies. And you just wanted to say, let her have the damn cookies. Because she was expressing to you what her joys are. Her joy at this limited stage was at least she could have a cookie. And we wouldn't even give her that. When we're frail or dependent, we hold the idea that safety and survival are your only priority, and that's intolerable for people. Thank you.
Wow. You guys are amazing. I just love both of the talks and the ideas about all of the issues involved in the natural history of the human species. So my assignment was now to make it even worse by talking about the non-natural, the unnatural history of the human species. I'm going to talk about genome editing. This is a topic that didn't exist 5 years ago. It's quite remarkable. So let me tell you a little bit about the scientific history, because you have experience with the things you know from teenagers and you know from older parents. You might not know from genome editing. So I was involved in the Human Genome Project. And, invariably people would come and say, well, now that you can find the disease gene for this disease, why don't you just go in and fix it? And as a scientist, you have to avoid sounding too condescending when you say, well, you see, it's not really possible to do that because you can't get into the cell and get into the nucleus and find just a single letter out of the 3 billion letters that's wrong. There's like no way to do that. And you'd say it politely. So it turns out we were completely wrong. There is a way to do that. And it had been worked out 1 billion years ago by, as usual, the smartest engineers on the planet, bacteria. They they know much more than we do. We learn sitting at the feet of bacteria. They don't actually have feet, but anyway. So we learned from bacteria that they have all of these amazing tricks. And so bacteria have been getting invaded by viruses for a very long time. And one of the tricks they learn to defend themselves is they take little snippets of the genetic code of the virus. They store it away in their own chromosome. And then they read it out constantly as little reminders, little memories of viruses that have infected them. And those messages that are read out into the material called RNA, not DNA, bind to a certain protein that has some name I won't bother you with, and that complex goes and searches and says, if I ever see that sequence of DNA again, I'm going to cut it exactly at that sequence. There is a GPS built into these bacteria, a genome positioning system, and it's perfect. So it turns out that this was a 20-year saga of discovery involving many, many people, and there are a tremendous number of heroes in this, but around 2011, 2012, and then January 3rd, 2013, comes out papers that say, you can take this from bacteria and put it into a human cell and direct it to any particular letter you want in the genetic code and cut there. And by the way, if you bring a repair template, you can repair it to that sequence. This burst on the scene then. I will note the institute I direct, the Broad Institute, has been extremely active in this. One of our faculty, Feng Zhang, has been a leader in this. There are patents all over the place and people arguing about patents. I don't care about any of that. I want to talk about the social issues, but I want to mention that fact. So in the space of the 4.5 years since this burst on the scene, it's being used in, 20,000 laboratories around the world. That's what happens in 4.5 years in my field. It's being used first for research. You want to make a mouse that models a human disease? Just send CRISPR in and cut at that right spot and put in the spelling that you want. Fantastic. You want to knock out all 20,000 different genes in a cell and a whole parallel to figure out which genes would protect the cell from a virus infecting it? You can do it. You can take a whole library of CRISPRs and throw them in and knock them out and see what happens. So there's a huge research explosion everywhere. But there's more. You can think about it for what's called somatic gene therapy. That means affecting the body of a patient who's here and now. Somebody who has, say, retinitis pigmentosum, a dominantly inherited disorder that causes blindness because of a bad protein being produced in the eye. Send in a little virus with CRISPRs and cut that bad gene. It's an interesting somatic gene therapy, and people working on that. Inject the muscles of people with muscular dystrophy and try to fix that. If people have familial hypercholesterolemia, huge cholesterol levels, you could, in principle, by injecting the liver, fix that. That doesn't involve such complicated ethical, legal questions because the person is there to consent and it only affects their own body. The really interesting questions come about germline therapy. Why don't we change the next generation? A couple has a genetic disease. They don't want to pass it on to the next generation. Let's gene edit the embryo so it doesn't inherit it. Huntington's disease, a terrible brain degeneration. We can edit the embryo so the embryo won't get it. Sounds great. Great, super, 5 minutes. So the embryo won't get that disease. This sounds very compelling, and everybody signs up for it. As a footnote, I just note, what you'd have to do is get in vitro fertilization. You'd get an egg and a sperm, fertilize in vitro, multiple of those embryos, and then edit the ones that have the bad copy of the gene. Alternatively, you could just take the ones that don't have a bad copy and implant it. So in that case, which is always talked about on the radio, it's not so totally clear you need it because you could do it by embryo selection. Only in rare cases will there be no chance of an embryo that might not inherit it. But nonetheless, people are very, very eager to go edit these horrible disease genes. But then go a step further. What about genes that affect more mildly your health? Why don't we make mutations in things that will decrease your risk of heart disease? How could you object to that? 20% less risk of heart disease. Or a favorite that a colleague at Harvard suggests, if I knock out one of your genes called FUT2, you'll never be infected by a norovirus, the kind of thing you get on cruise ships where you throw up for 2 days. It's terrible. So the point is, though, he didn't realize that knocking out that gene would protect you against noroviruses, but it also would suddenly lead to about, if we did this in everybody in the United States, about 100,000 more cases of inflammatory bowel disease with a tenfold higher risk of colon cancer, etc. In other words, genes, genetic variants are mixed blessings. They decrease risk of some things, and they tend to increase risk of other things. And we're not so smart yet. We're not as smart as we might think about what all those effects are. But people are very eager to start doing it because they see one effect, and they'd like to get that good effect even though they don't know the rest. And then there are other things. There's a Finn who won 7 Olympic gold medals in endurance sports because he has a natural mutation that causes overproduction of erythropoietin, EPO. That's something you're not supposed to do as illegal doping in sports, but he's got a natural mutation. And great. So why not, if you want kids who are going to be really good at endurance sports, put in an EPO mutation? Or why stop at naturally occurring things? Why not try entirely new circuits, clever new circuits that have been arranged of multiple genes that do bold new things? So it raises a lot of fun questions. What will the product recall notice look like? Dear Mom, it turns out that the genetic innovation in Johnny was not a good idea. We suggest Johnny doesn't reproduce. That's going to be an interesting notice. The clever new genetic circuits that are put in Johnny and Mary. We can worry about the safety of each individually, but then there's the question of, are they compatible with each other? Whole new opportunities for matchmaking arising here. Geneticists say, who might be newly incompatible because of this? What happens more philosophically when we regard children as products of manufacture? Mom, why did you do that to me? Or, Dad, why didn't you do that for me? It's an interesting world. And then who decides? When we make changes that are permanent changes to the human population and we cannot call them back, who decides those questions? The National Academy assembled an international summit about 1.5 years ago on this topic. I was on the committee that was asked to write a statement. All the scientists, we agreed on one part of the statement, which was safety. We've got to make sure it's safe. That technically, when you make these genetic edits, it doesn't cause damage to unintended things. That was the easy part. We then added a second part to the statement. For each application, there needed to be broad societal consent. Various people have asked us, what did that mean? We have said that's exactly the point. It's not clear exactly what that means. We wanted to understand, we wanted to say you had to get broad societal consent and you had to struggle with what that could mean. There isn't, you must get a majority vote in this or that, and which country, because we are going to have to, if we make permanent changes to the human gene pool, to our population, we are going to need consent. When Monsanto tried to introduce genetically modified organisms without societal consent a couple of decades ago, it backfired badly, and we've never regained public trust. For my part, I would not advocate doing this, but it is a very live question right now in the broad community of should we do this. And so figuring that the natural problems we have are insufficient, I thought I would add the unnatural problems that we will face as well.
You left me for last. She hasn't started the time yet, so I can make the observation I'm the only one without a medical degree or a PhD on this panel. But luckily, we outnumber them, so I thought I was good company. It's true, right? So the title I chose was Parenthood Disrupted, with the question mark in parentheses, very deliberate. Because I want to ask whether new technologies are going to disrupt our social or legal conception of parenthood. Disclosures about not promoting anything here. I have nothing, maybe promoting good old-fashioned sex, but I'm not promoting any product or therapeutic or anything like that. Mostly I'm using this talk as an eye-opener to you to kind of flag 3 technologies. A lot more technologies I could have picked. Could have picked gene editing, in vitro gametogenesis, so taking a skin cell and making sperm or egg out of that. Could have picked artificial wombs, egg freezing, embryo disposition, but I chose 3 that are in practice right now and still at the cutting edge. First one is uterine transplants, right? So I like to say Harvard Law School had come a long way in 200 years from the borrowed servant rule to the borrowed uterus rule, right? So essentially this involves taking a uterus from one woman and using it in another to have a successful pregnancy. It began after there was a living donor in Sweden in October of 2013 that had a transplant essentially of a uterus. And there are trials occurring here in the Boston area. There have been trials that have gone on in the Cleveland Clinic. The main clinical reason to do this is uterine factor infertility. Women who are born without a uterus have lost their uterus, or their uterus no longer functions. And essentially how it works is the intended mother's eggs will be removed and fertilized with her male partner through IVF, if there is a male partner. They'll then look for a uterine donor. Most of the protocols in the US are focused on cadaveric donors, that is dead donors. Just to take a step back from this, we're talking about essentially bringing new life into the world through the uteruses of dead people. It's really amazing that we're at this point technologically. Once the donor is found, the recipient goes on immunosuppressive drugs, and the uterus is transplanted onto her pelvis. Everything goes well. After 12 months, it's healed enough that they can carry a child. And essentially, she'll undergo a C-section delivery. And the idea is you'll have 1, maybe 2 children this way, and then the uterus will be removed so you can go off immunosuppressive drugs. So this is an amazing, amazing technology, but it raises a number of interesting, perhaps disturbing legal and ethical questions. First of all, is this a technology we really should be supporting and paying for and researching? How important is pregnancy on top of genetic parenthood? The mother would be a genetic parent, whichever way. We're talking about here about giving the experience of pregnancy, although it's not exactly like the experience of a normal pregnancy. Should we be allowing women to undergo the risk of transplant for what is in some senses an elective experience, to experience pregnancy? Should the state pay for it the way Medicare, for example, pays for kidney transplant? What about private insurers? Or is this only going to be available to wealthy women? Does it matter whether surrogacy is available as a legal alternative, given that this involves more risks to the recipient woman than surrogacy? By contrast, if surrogacy is available, is it immoral to engage in surrogacy when you could do this instead? Because you're shifting whatever risks of pregnancy, whatever exploitation onto the surrogate when you could internalize those risks. Should we consider living rather than cadaveric donors? Is it a positive thing, for example, there are cases like this in the literature, if a mother gives her daughter her own uterus so the daughter can produce a grandchild for mother? How do we think about that grandmother who's also a uterine donor? Is she grandma? Is she mom? Is she mom asterisk, gestational only, right? Is there a new term and a new conception we have to have here? Should the legal rights of a grandmother who's a uterine donor look different from the rights of a grandmother who's just a regular grandmother? What happens if there's parentage disputes? Can she make a claim to parent the child? Going further in the future, we might in the future be able to allow trans men, that is female to male trans individuals, to carry pregnancy this way, right? Or male to female trans people to do it this way. Indeed, regular men might be able to implant a uterus onto their pelvis, right? So pregnant men, truly genetically men becoming pregnant. How do we feel about that possibility? Would we think that abortion rights would be different for a man who is carrying a baby in this context than a regular context? One technology out of 3. Second one, mitochondrial replacement therapy. Currently approved in the UK, not approved in the US. Mutant mitochondrial diseases in DNA give rise to a broad range of heritable clinical syndromes. And there's some disputed literature, everywhere from 1 in 200 children to 1 in 5,000 children born with one of these diseases. And they're awful diseases. They are diseases of seizures, early death, developmental delays, etc. But we can do mitochondrial replacement. We take the mitochondria from a mitochondrial donor, we nucleate it with the egg of a regular woman who has mitochondrial disease. We fertilize it through in vitro fertilization, and then we implant it. So you have some mitochondrial DNA from one woman, you have the rest of the DNA from another woman, and you have DNA from a man. We have 3 parents. I don't love the term 3-parent IVF, but that's how it's been referred to. And this slide shows one of the ways to do it. The FDA commissioned a very thorough and thoughtful study from the Institutes of Medicine, the National Academies. And then, in the interim of that study, Congress passed a statute, a rider actually, an appropriations rider, preventing FDA from considering certain kinds of technologies. And FDA has interpreted that rider, mainly aimed at gene editing, what Eric talked about, to encompass MRT. In fact, the National Academy still issued their report, and they recommended that this perhaps go through a regulatory pathway carefully. And what was most interesting is they recommended that there be male-only embryos for this, because the male embryos will not have had the alteration of the mitochondrial DNA while the females will. So what do we think about this? What do we think about the mitochondrial mother? Is she a real mother, even though she's only giving a small fraction of the DNA? In a country that requires donor non-anonymity to identify sperm and egg donors, should a mitochondrial donor be identifiable at age 18? Is this a problematic crossing of the germline threshold? Should that make us restrict it to male only? We did restrict it to male only. That would essentially be FDA requiring sex selection, right? So that would be government-required sex selection. Is that problematic? And in the cases where we do engage in medical sex selection and it's endorsed by governments, it's typically to save and help the next generation of offspring. This is not to do that. This is about future transmission down the line. Is that different? Okay, last technology. My mother used to say, when you're dead, you're dead. Like, live your life, have a good life. But it turns out, even though you're dead, you can still have children, believe it or not. That is not only in the case of banked sperm, that sperm you put away because you are undergoing chemotherapy or because you're trying to start a family, but in fact, even if you're dead for a certain period, at least 24 to 36 hours, that's the recommended period, actually considerably longer, we can harvest your sperm. We can do it by injecting a needle into your testes. We can do it by surgically extracting the testes. Or I think the most interesting is that we can give you an ejaculation after you're dead. So I like to think of this as ghost orgasms, right? We can insert a conducive probe into the man's anus until it's next to the prostate, use some electricity, and there we go, right? Ejaculation happens. We've been using this for animals for a very long time. It's also used for men who are living who have spinal paralysis. Under what circumstances should a hospital allow this retrieval to take place? Under what circumstances should we allow the sperm to be used? Photo here is from a Times of Israel article I'm quoted in, and it involves what's become a recurring fact pattern in that country, which is young men killed during the pendency of their military service, and their parents, that is the men or would-be grandparents, wanting to find a surrogate and use sperm that has been recovered to produce the child, sometimes over the opposition of the man's widow or the man's girlfriend. Lots of interesting problems here. Talking about children who will be born in some senses into orphanhood, or at least having their grandparents who are going to rear them die at a fairly young age for the child's life. Should that matter? Should we pay attention to child welfare issues, or do we think it's problematic to do so because the counterfactuals of the child not existing at all? Should we require advance directives, or is a conversation between the reproductive parties that's very general? You know, I really, really want to have a child, right? Asterisks, did we discuss having a child after you're dead? I can't remember, honey, right? Should that kind of general sense of intent be enough here? What role should a widow or girlfriend have as against the parents if the parents want to go forward with this? I mean, after all, despite what parents might like, they can't force their children to produce grandparents when they want to, produce grandchildren when they want to. Why should it be different after they're dead? There's also been cases of circumvention tourism, as there are with mitochondrial replacement therapy, people taking the sperm outside the country to try to do this. Should we have an international treaty on this? What about extraterritoriality? Finally, in the US, the most common fact pattern that has raised this is money, right? They say where there's a will, there's relatives, right? In the sense that there's been a fight over who inherits in terms of posthumously conceived children. So do posthumously conceived children receive Social Security benefits from the government? If there's a trust that has an open class, to my descendants and heirs, I skipped trust law as a student. I went for the bar, so I'm going to get it wrong. But those of you who are trust lawyers, know what it's supposed to sound like. If there's a trust, at what point do posthumous children are included? Can they come into existence 10 or 20 years after the last born child? Does it matter if they reduce the share of the other children? So these are great issues. This is why I love my job. I get to teach, think, and write about this. And I'm going to enlist you during the Q&A to help me think about it a little bit more. Thank you very much.
Okay, so this section I like to call Talks Amongst Yourselves, because we're hoping that you guys will have a really interesting discussion in front of us, perhaps even an argument. We're all looking for juicy drama. So one thing that I noticed is that this panel covered pretty much the entire human life cycle, from conception or even before conception to some teenage shenanigans to end of life. Do you see new technologies as producing different problems at each stage of life, or are there commonalities in the challenges they pose?
I'll jump in and say I think one thing that's hard about children and about before birth is the lack of a consenting person, and it's also hard at the back end of life where we have questions about consent, and one of the things I love about Judy's work.
I want to make one nerdy observation because I was time limited in my limitations and my humility section, which is usually in my talks. I didn't have time for humility. But when you're talking about juvenile adolescent brains and adolescent neuroscience, one thing that you really have to talk about is the group nature of this data. So when you're looking at my predictions of reckless, thrill-seeking adolescence, that data is group data generated from grouped brain scans and grouped functional brain scans to predict what an average adolescent would do. And when you're using that data, you have to understand that the average isn't always the person in front of you, and we have no way at the moment, although it will be soon, to individuate the data. So does the 12-year-old before you have a brain that looks like a 19-year-old? Does the 19-year-old before you have a brain that functions more like that of an average 14-year-old? And the data is on well, non-traumatized, privileged BBNN students who want to get an A in human biology. So they come to Harvard and they get scanned, or they go to Columbia and they get scanned, and they go to Stuyvesant, and then they go to... So these are not average adolescents, even though the data is averaged. So one of the difficulties is you always have to pay attention when you're translating science. If you have group data, there are going to be translational issues with respect to individual data. The data that I showed you with respect to older folks is a little different, because you're talking about lesions and illnesses that are individuated. In some way, that's an easier ethical and legal problem than deciding who belongs to a group of people when you have group data. We can talk more about that.
Wow. So I agree, consent is clearly at the heart of a number of these issues, and I guess the legal fiction of the reasonable man, that is the lack of recognition of inherent variation of circumstance, whether that's physiological brain circumstance, genetic circumstance, or if we're going to really get serious about it, there are life circumstances. If it turns out that the teenager, we ought to actually pay attention to the fact that that teenager has a brain that isn't really capable of making these kind of judgments, well, do we also pay attention to the person who's had a tremendously traumatic life, not tied to any physiological thing, and say that too affects their culpability and responsibility? Does the law have to take people as individuals, or can we squeeze them all into the reasonable man? So I think all these things are tugging at how we think about inherent real variation now that we confront that it's real, it's not just an excuse.
With respect, and that's so perceptive with respect to juvenile neuroscience in particular, and a lot of people in this room are interested in that. The question of what is the entitlement to a healthy brain? What is healthy neurodevelopment? Because the people in the world aren't like the kids who come get scanned. They have psychiatric disorders, they have substance use disorders, and they have traumatic life circumstances. So if you talk to a colleague of yours and on our faculty, Chuck Nelson at Children's Hospital, or Leah Somerville over at Harvard Faculty of Arts and Sciences, what they would say is something really interesting, that the stressors, chronic stress, violence, deprivation, trauma, all of those are written on the brain, and they're written on the brain in the period in which the problem exists. So they would say something which I think is a great metaphor, and when you're translating, you need metaphor. Moving parts get broken. So the faculties of the brain that are coming online from age 3 to 5 will get broken if you stress them during those periods. And adolescent self-control, lack of impulsivity, future thinking, risk assessment, those faculties will be harmed if you pickle these kids in stress and violence and deprivation. Moving parts get broken.
The only thing I'd add in is that our sense of being impaired doesn't just evolve over time and be individual from person to person, but it's also individual in time itself. That is to say, we all have our significant moments in our life where we are poor decision makers, we're limited, so that the notion of informed consent, a lot of our work in our research center is around the fact that clinicians themselves are often fluctuating in their own capabilities and their own judgment, and therefore needing to build systems around them that reduce that variation and enable you to kind of function with people who are fluctuating in their own abilities all the time. 28% of us will have major Axis 1 mental health disorders at some point in our life. And that is essentially saying that's a normal part of life in our own families, and then add in the stressors of family breakdown and other things that you just talked about. And so the puzzle that then comes out is, are we better off, it really is just an empirical question in my mind, are we better off treating people as if they are rational, or are we better off treating people as if they are mostly irrational? Because one leads, in a sense, our democracy, our court function, and so on, has recognized the fact that we are, long before our neuroscience ever got there, that we function pretty irrationally for significant parts of our life, but it's better off than systems that treat us as functionally irrational, because then who is to make the decisions in the absence of our own capabilities? There is no higher judge better than ourselves when you begin to recognize that nobody is the reasonable person. It's not like you can say, well, teenagers and elderly people are not reasonable, but everybody between the ages of 25 and 54 are therefore the kings of the world. And so the functional apparatus of being able to drive decision making is really looking at, to me, an empirical question more than simply being able to lay out straightforward principles.
So earlier in the panel, Atul, you mentioned the very robust debate that happened over healthcare this summer, and Eric, you mentioned the debate over genetically modified food. I wanted to ask this panel, who do you see as the key stakeholders in the response to new technologies, and if you think there are voices that need to be louder in these conversations?
Well, one thing that struck me is is what gene editing is forcing, and to some extent, some of the technologies that Glenn is talking about is forcing, is that the decisions that individuals make have societal consequences, and therefore it broadens and narrows the sense of autonomy, so that you have individuals who have the capacity to cause system-wide effects. And I think one of the other interesting aspects is that as we come to recognize how your own actions and variations turn out to have ripple effects that go very far, that we're having to deal with the fact that our very nature of our deep interconnection, our globalization, our communications technologies, our ability to also work together so effectively so we can take on incredibly ambitious tasks like simply providing healthcare to people who are enabling us to double our lifespan. All of that requires us to be navigating this pathway of group consent, and in a certain sense that takes us back to sort of traditional societies where no one in my father's village in India made a decision by themselves. They were group decisions because they carried impact for an entire subsistence village. And even your choice of who you marry or your choice of what job you take had such deep impact on the survival of the group that was a normal set of considerations. And in some sense, our interconnectedness is leading us to have to make, at the size of millions instead of 5,000, an understanding of what social consent might really look like.
Boy, this is, the stakeholders are diverse and pretty complicated here. There's always somebody who has some urgent need to have this technology now. The couple that they have a double dose of Huntington's disease and they can't have a child who will be free of the disease because they're, as we say as geneticists, homozygous. And they must have access to this technology because they feel they have a right to have a genetically related child, and they feel that strongly. And then there's the backfiring of what happens if we go down that path too quickly and how it might deny that technology, whether it's GMOs to people who desperately need that in the developing world, or to families or patients who need somatic gene therapy. So there's always this urgency that is attached to it. And being able to proceed with some care, being able to say, in cases like this, I'm sorry, we don't have to move this fast until we actually understand is hard, because doctors and patients feel they have a right to make that decision, and we respect their autonomy in so many ways. And yet, it does backfire when we don't proceed with caution. But when I say, boy, I'm not up for gene editing the human population right now, a lot of my scientific colleagues say, oh, you're such a stick in the mud, you can't stand in the way of progress, et cetera, and not just my scientific colleagues. I think surveys show most people, the reasonable man and woman who is reasonably uninformed about this, are all in favor of going forward. So, yeah, it's tricky.
I'll just add, so William Gibson once said, the future is already here, it's just not very evenly distributed. And I think that's quite true, right? In that people who are high net worth individuals have the option of shopping for a different regulatory regime. And one of the biggest challenges with a technology like gene editing is if your choice is ban it at home, is it going to drive people to an even less regulated jurisdiction where we don't even have the kind of minimal or medium level regulation we'd want to have here if we were doing it. And that's an empirical question, whether it's going to happen or not. And then you think about children produced through gene editing, if we're really serious about protecting our population's genome, right? Are we going to turn them away at the border? Are we going to tell our kids who go out backpacking, right? Well, be very careful and ask a lot of questions before having too many drinks, out in Barcelona one night. You never know. You might get pregnant with somebody who is themselves the result of gene. It just seems impossible to keep ourselves away from this. So we have to, if anything, move to more of a transnational model of regulation.
But I do want to add, we had this international meeting organized by the Brits, the Chinese, and the Americans. And there was all this discussion in the media about how people would go do it in China, and China would do it anyway. I learned then that China has much more strict regulation of its IVF clinics than the United States does. And they're actually taking the problem at least as seriously. So you're completely right, the transnational questions, but we shouldn't imagine that we are necessarily the strictest jurisdiction with regard to these